Last lesson introduces two topics, one of which you probably have a good understanding of, but I'm going to give you a little shortcut, easy way to get it. The other is a little tricky to understand, okay? And you're just going to have to go with it. So, distance, I bet you guys know how to find distance already. Get the thing out of your ear. I'm going to give you a helpful, not tricky, I'm going to give you a shortcut way to find a distance, though. If you have a calculator and you want to get the answer really quickly. Average, this is where things get a little tricky. Okay, so we'll spend more time on average. Why do I think you guys already know distance? Well, you spent the last couple days understanding this sign chart. The analysis and the next level of our analysis, which is the area under the velocity, is our displacement, which can be used if you have a position to find future position. If this was a sign analysis of my velocity over 0 to 4 seconds, and these are my displacements, you can tell me the distance traveled and the overall displacement from 0 to 4. Okay? Distance is like total amount traveled. We're not going to define it using notation yet. Displacement is literally your change in your position, your velocities times your times, which is equivalent to an ending position minus an initial position. Okay, tell your neighbors, over the 4 seconds, what is your distance traveled and what is your displacement over the 4 seconds? Go. See, you already know how to find it, okay? You already know what to do. Oh, I increased 6, I went to the right 6. I went to the left 12, I decreased 12. What was the total amount traveled? 18. What was the total displacement? Well, over the course of the 4 seconds, -6. I ended up 6 to the left of where I started. If I gave you a starting position, let's say x of 0 was, 2. Well, x of 2 would have been 8, and x of 4 would have been -4. Okay? Overall, I ended up 6 to the left of where I started, but how did I get there? I went to the right 6, I went to the left 12. So you guys already know distance. So, if you had a calculator, and I gave you a velocity, and I asked you to find a distance, even though this is such an easy velocity function, what you guys probably would do would graph velocity. You probably immediately do that if you were given a calculator. Am I right or am I wrong? You probably would put down a sign analysis, and you probably would go through the trouble of finding your intersection. You might even list it off as A, when in reality it's just 2, guys. It's just going to be 2. But I bet you would have found that intersection because I gave you a calculator. I bet you would have gone through the trouble of using an integral to find your displacement, even though you could have figured out that it is a straight line and it's a triangle with a base 2 and a height 4, so this is going to be 4. You probably would have used an integral to get +4, and you guys would probably use an integral to get this as -4, and you would have done all that work to get your answers for your displacement and your distance. So at least give me the answers, and we'll now start using notation for distance. What is the displacement for this situation? What is the distance for this situation? I'm doing all the work for you. You just finish off with the answers. We have the answers, right? You guys know the answers, right?
I told you off. Then it's under control.
Okay, guys. You don't have to know position to know change in position is 0. I go to the right 4, I go to the left 4. You don't have to know position to know distance. But if you had them, you could use them. Now, how did we find it? We looked at the overall area under my velocity. We could have also done the change in position, but I didn't have it. But if I had it, I would have gotten 0. I didn't have it, but if I had it, I would have gotten 0. Now, for distance, what did we do? You took the positive area from 0 to 2. You kept that positive. You took the negative area from 2 to 4. And what did you have to do with these two so that you get positive 8? So it brings up what a lot of people kind of come up with a lot quicker than they usually do. The idea is like, well, I took positives and I kept them positive. I took negatives and I made it positive. We're not there yet. I kind of like subtracted that negative to get a positive 8. But what I'm about to show you is that there is a quicker and easier way to do this. Okay, so here's your trick to distance. You guys already know how to find distance. You guys know how to do this sign analysis. You know how to find displacements. You know, add them up as positives. There's an easier way. Okay, here's your trick. What is an integral of velocity? It's multiplying velocities times time. Well, let's think about what the absolute value of velocity means. What is like a physics meaning to the absolute value of velocity? Speed. The absolute value is speed. Now watch what happens if I look at the absolute value of velocity here in red. It would be positive, and then instead of going to negative, it would stay positive, which means this area of 4 would stay 4, this area of negative 4 would turn into positive 4. We could get this answer 8 without doing any work whatsoever, just by going 0 to 4 of the absolute value of v. And instead of multiplying velocities times times, your calculator will multiply speeds times time. This is your shortcut. Go ahead and type that into your calculator. Your velocity is negative 2t plus 4. You guys know how to type in an absolute value? Well, that's something you need to know how to do. So let's practice finding the absolute value. I can get the number 8 without doing any work whatsoever. Negative 2t plus 4. All right, now. We go 0 to 4. We go math. Go over. Okay, everybody, here's how you access the absolute value. Math button. Pop over to num. Add. Math num add. Negative 2t plus 4 is your velocity. Plugging that into an absolute value and having your calculator, again, your calculator does a numerical process. It adds a bunch of things together quickly. It does not take antiderivatives, which is how you have to do things. And it gets the answer 8 without doing any work. Okay? So really, the first half of this lesson is, what do you got? If you have a calculator and you're asked to find displacement, piece of cake. Plug in velocity into an integral and you get a displacement. It'll give you a correct positive or negative value. You don't have to do a sign analysis. You're done. You want to find a distance. Great. If I have a calculator, I would just plug this into my integral and do zero analysis, because this will do velocity times times in a calculator. This will do speed times time. And that will give me the right answer. Now, if I don't have a calculator, how do you find a displacement? Tell your neighbors. If you don't have a calculator, how do you find a displacement? You don't need a sign analysis for displacement. You just need your change in position. This is when we take an antiderivative to find an area. Go back to the original situation. If I told you x of 0 was 2, x of 2 was 8, and x of 4 is -4. If I asked you to find the displacement, 0 to 4 vdt, you could take the antiderivative, get a position function. It will have a c in it, but you don't need c if you're subtracting your position at time 4 minus your position at time 0. The -4 minus 2 gave you the -6. That is how you can find areas. You take antiderivatives. So don't forget this. This is what human beings had to do to find areas. Now, unfortunately, we don't know what the antiderivative of an absolute value function is. And I'm not going to teach you it because I don't know it. It's like complicated. So really, without a calculator, if I'm asking you to find a distance, you need to do a sign analysis. And after doing a sign analysis, you'll need multiple b's minus a's of position. Okay? But you're used to doing a sign analysis. You're used to finding, the displacements potentially either using position or using the area under velocity, which really is found the same way. Okay? So, here's the situation. I give you a calculator. Go! You probably have this saved in your calculator from earlier today. We use this function. I just erased the 5. Erase the 5 for me. It'll make it findable in your calculator. Don't use the -5. Heads up for your homework. If you're finding displacement and distance, it's easiest to find the distance first, and then you can delete the absolute value. It's harder to add in an absolute value, but that's all you do. I did this earlier today. I got 21.211. And I got 20.516. I hit delete. What's going on? What's going on YouTube? Now, I know, right? Now, guys, we looked at this function earlier in the class when we were preparing for our quiz. Look at the work that we did earlier today. We had that velocity. You graphed your velocity, And what did you do? You did the sign analysis. Look at these two numbers, 20.864 and negative 0.347. If you add them together, you get that 20.5 value. If you add them as positive, you get the 21.212 value. Okay? So you can do this whole sign analysis, and maybe as you're doing your free response question on your test, you're already doing the sign analysis, which means like you don't have to do the absolute value. Like you know how to get the answer based on this work that you've done. Okay? You could also, depending on the situation, if you know your position's increasing and decreasing, you could use these values. The 2.347 minus the 18.516 gives you the 20.864. The 2 minus the 2.347 gives you the negative 0.347. This is a way to find your displacement if you have the position. And there are some situations where you can utilize that very situation. Look, I'm asking you to find the distance. I don't even want you to set it up. I want you to find the distance that you travel. Okay? But you don't have a calculator. And this is a position function. Again, I'm changing it so it's easier to do. Change it to X, erase everything, and just say no calculator, find the distance. Watch. Going to do a sign analysis of V because that's the key for so many of our questions in this unit. And it will be the key for our distance questions too. X prime is V, 3, 0, 5. Positive until 3, negative from 3 to 5. We looked at this very same function earlier too. I think the number was over there. That tells me my position increases and then decreases. What's easy to find in this question? Positions are easy to find. The max is easy to find and the location is easy to find. What are your positions at these 3 times? Because you have found these doing your maxes and mins questions from the quiz and from your homework. Well, x of 0 is negative 8. Great. I plugged in 0. I got x of 0. X of 3 is 9 minus 8. That's 1. X of 5 is negative 25 plus 30, which is 5 minus 8. That's negative 3. Yo, these were so easily found. And now you can answer the question. How far did I travel? What was my displacement? Go. How far did I travel? What was my displacement? I got position. These are my positions. These are my signs of my velocity to tell me my position increasing, decreasing. These are my positions. Right, find my position because I have my position function. You're getting me ill like that. It's okay. We good?
Yep, we're good.
All right. You got the answer now to the question. Right. Now, look, you get it. Yo, guys, sometimes without a calculator, we realize, oh, this is great. The area under my derivative, which is my displacement, I can find my displacement from the change of my position. I increase 9 to get from negative 8 to 1. X of B minus X of A. From 1 to negative 3, I decrease 4. you found your displacements, you found the areas under your velocity without having to do anything with an integral. And now you can answer that your distance has to be 13. Your displacement has to be 5. From -8 to -3 plus 5. Isn't that cool? So this is a no calculator way of answering some questions, of doing your analysis, which is nice. But we got to move on. All right, ready? Now let's go to the tricky stuff. All right, shush. Okay, I'm going to write something down. You're going to tell me what it means. Please don't say slope. What does that mean, x of b minus x of a over b minus a? Average rate of change of what is very important. We can always say average rate of change, but of what? That's important. Good. This is the change in position over the change in time. We've called this how quickly my position's changing over an interval. It's an average rate of change of position. Is that cool? Okay. What is the physics term used for how quickly position is changing? Velocity. An average rate of change of position is an average velocity. Cool. Well, we actually knew this in lesson 1. But after lesson 2, we got to actually change things. Because we know that the area under velocity, which is your velocity times your time, can be found by doing the change in your position. Watch what I'm going to do. I'm going to keep this b minus a in a denominator, but I'm going to move it to the side and put it under a 1. Cool? We comfortable with that b minus a being right here? Now I'm going to take this x of b minus x of a and replace it with an integral. And what we have is just another way of writing this. Cool? So an average velocity is an area under a velocity times 1 over b minus a. Now this is something that is kind of confusing to students, but let me try to make sense to it. What do you guys know about averages? If I ask you to find the average of something, you were probably thinking add all the numbers up and divide it by the amount of numbers, right? Like averages, means. Well, what is an integral? What does your calculator do? It adds a bunch of numbers up really quickly, okay? And then what are we doing? We're dividing by the interval, or like the amount of numbers that we're coming from. Maybe that like kind of connects what you know of average and this new way of looking at averages as being areas times an interval, divided by an interval, really. Okay, now, what gets funky is when I keep going. I can do the same thing with v of b and v of a. And we know this is going to be how quickly velocity is changing, the average rate of change of velocity. But what is the physics term used for the change in velocity? Acceleration. So this is average acceleration. Now here's something we haven't done. Did you know that if you looked at the area under acceleration, well, you would have to take an antiderivative and you'd get a velocity, and you'd have to find the change in your velocity. We have not done this. We've only worried about the area under velocity, the area under my first derivative, because the area of the first derivative gave me the change in position. I know like where things are, how things move. But now we have an application of, hey, If you want to look at the area under velocity, you can know how much your velocity, area under acceleration, and area under a second derivative, you'll know how much a first derivative changes. So all of a sudden, I have this formula now. Okay, so an average A, this is our new formula for what we can think about in terms of averages. An average V, this is a new formula. Now, the next one is where it blows students' minds. If I ask you about an average position, like where are we located on average over an interval? If you follow these formulas, you'd say, well, it looks like it's 1 over b minus a, integral from a to b of, well, a, so average a, I need a in an integral. Average v, I need v in an integral. Average x, I need x in an integral. But how do you find this without a calculator? You would need the antiderivative of x, or you would need big X. Many times in the last 2 units, students are like, Mr. Messner, why would I take the antiderivative of x? Why do I need big X? Or why would I take the antiderivative of position? Like, what do you get if you take the antiderivative of position? Well, what you get is the antiderivative of position. But what you can use the antiderivative of position for is to help you find an average position. Again, this is tricky. You're going to have to just go with it. The key to this, and this is new, is that if you want to find an average of something, you're going to have to do 1 over b minus a, integral from a to b of that something. You will hope that you have a calculator, and you can just type this in. Hooray! If you don't have a calculator, you will have to take the antiderivative of that something. So for example, let's pretend we have a calculator. And you're going to change this, erase this. I give you a position function, and I ask you to find the average position. Okay? Get the answer with your calculator quickly. I think it's negative 15. Or negative, I don't know. If somebody thinks they have it, I think it's negative 14 or 7 or 15 or something like that. But let's see if you can do it. See, everybody now starts to like second guess what goes into an integral. B minus a should be 2. Negative 15. We should get negative 15. We should get negative 15. Ready? Keep it simple. And with averages, it's going to take you a while to get out of your like idea of what is an average. Here's a new understanding of averages. Average of something, 1 over b minus a, integral from a to b of that something. You should do 1 over 4 minus 1, integral from 1 to 4 of what we're trying to find the average of. So you should be typing into your calculator 1/3 integral from 1 to 3 of negative 3t squared plus 6. It's like the dividing part of an average. It's like dividing by the integral. It's like this. You have to divide by the time to figure out the rate of change. Your change of your position over the time in which that position changed. Well, look, you see this b minus a, you see this b minus a, this b minus a? There it is. Just moved it to the side and put it at 1 over b minus a. And then I replaced v of b minus v of a with an integral. X of b minus x of a with an integral. Okay, Now, hold on. You get an answer. Could you get the same answer flipping your calculator over? Okay, don't use your calculator. Get that same answer, -15. This is important. Now, this kind of really springboards us into more calculus, like next unit, unit 9, unit 10. Yo, don't worry about what you have. Don't worry about the fact that this is a position. If you want to find an area under a position, you need the antiderivative. You might be worried about the plus c. You might try to think to yourself, oh, this is big X. I don't care. To find an area, I'll take an antiderivative. Thank you, Mr. Newton. I take an antiderivative, and I will plug in 1 and 3 into it to get the big X of 3 minus the big X of 1. The average rate of change of big X gives us the average regular X. That's confusing. So we don't worry about that anymore. The average X, 1 over b minus a, integral from a to b of X. How do you find the integral? You have to take an antiderivative. All right, so I get -27 plus 18 plus c, but it's going to go away, so we kind of cancel it out. And then I got -1 plus 6. Let's see. You will need to be able to do this. This is -9 minus 5. -9 minus 5 is -14. Did I screw up here?
Yeah, I think you went 1 to 3 instead of 1 to 4.
Sorry. Four cubed is what? 64? -64. This is positive 24. All right, that's going to work out. That's -40. -40 minus 5. What did I do? -40 minus 5 is -45. -45 divided by 3 is -15. There we go. Okay? So, on your homework, you need to make sure you understand, with a calculator, things are pretty easy for distance. With a calculator, things are easy for averages. Without a calculator, you have to do a little bit more, whether it's a sign analysis or it's a little bit of antiderivative find areas.